This question is from GATE 2017 Mechanical Engineering paper Set 1, question number 42. A rectangular region in a solid is in a state of plane strain. The x, y coordinates of the corners of undeformed rectangle are given by P 0, 0, Q 4, 0, R 4, 3 and S 0, 3. The rectangle is subjected to uniform strain epsilon xx equal to 0.001, epsilon yy equal to 0.002, gamma xy equal to 0.003. So this is the axial strain in x direction, axial strain in y direction and the shear strain in xy direction. The deformed length of elongated xy diagonal up to 3 decimal places is dash units. Let's find out. We'll start by writing the given things. As I already mentioned, epsilon xx, the axial strain in x direction, is given as 0.001. Strain is unitless. It's a pure number. In y direction it is epsilon yy 0.002 and the shear strain gamma xy is given as 0.003. We are also given the coordinates of corner points of the region. So we can plot the rectangular region using those points. This is that rectangular region. This corner point is P 0, 0. This one's Q 4, 0. This one's R 4, 3 and this one's S 0, 3. Length of side PQ can be found out. Q has coordinate 4, 0 and P has 0, 0. So distance between the two is of 4 units. Similarly, distance between P and S is of 3 units. So QR will also be equal to PS because this is a rectangle. Opposite sides are equal to each other in length. Now we need to find out the elongated length of the diagonal. So PR is the diagonal which is making an angle theta with the side PQ, and we need to find out how much has the length of diagonal changed when this rectangular region is subjected to these strain values. This gives us an axial strain in x direction, this gives us an axial strain in y direction, and this gives us the shear strain. So definitely when there is shear strain, the element is not just going to expand but it's also going to rotate by its sides. So the new shape will be something like this. And therefore the diagonal will also be lengthened. This will be the new diagonal by the virtue of these strain values. Length of this green line we have to find out, which is the elongated diagonal PR. Or we can write the new position of R as R dash. P remains the same. We have to find the length of PR dash. In order to find this length, we will first find out the strain. And as we know that strain is change in length upon original length. If we manage to find out this strain, we will be able to find out the change in length. And once we know the change in length, we will just add it to the original length to get the new length L dash or PR dash. So let's do that. We'll first find the strain in theta direction. For any planar element that is subjected to strain in x, y direction and shear strain, we can find out the strain in any direction theta inside the element by using this formula. So this formula you must know in order to solve this. Strain in theta direction is equal to delta L by L, which is equal to, and L here is nothing but the length of PR. This formula is written as epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos 2 theta plus gamma xy sin 2 theta, where theta of course we need to find out using this geometry. Triangle PQR is a right angle triangle. Therefore we can find out theta using trigonometry. Theta will simply be tan inverse, because tan theta is opposite side upon adjacent side. Theta will be tan inverse of opposite side QR, that is 3 units, divided by the adjacent side PQ, that is 4 units. This gives us theta as 36.86 degrees. We know theta, we know all the values of strains. Let's substitute here and find out epsilon theta. So we have epsilon theta is equal to 0.001 plus 0.002 divided by 2 plus 0.001 minus 0.002 divided by 2 cos of 2 times 36.86, which is 73.72, plus gamma xy is given as 0.0015, again sine 73.72. This first term turns out to be 0.0015. We find it out in the digital calculators very simply. Plus this term has to be negative. It's minus 0.0005. And cos of 73.72 is 0.28 plus 0.0015. Sine of 73.72 is 0.9599. Evaluating this, we get strain in theta direction is equal to 0.002799. From here we can find out the change in length, because this is equal to change in length upon original length of the diagonal. So this gives us change in length delta L is equal to L into epsilon theta. Length of the diagonal will be, using Pythagoras theorem, root over 4 square plus 3 square, because diagonal is the hypotenuse side, into 0.002799. Let's find out. Delta L turns out to be 0.01399, which is approximately equal to 0.014. Now let's find the new length PR dash or L dash for the diagonal. This will be equal to PR plus delta L, which is equal to 5 plus 0.014. This gives us the answer as new length of the diagonal as 5.014 units. Let's go back and fill in the answer. So the deformed length of the elongated XY diagonal up to 3 decimal places is 5.014 units. To learn more about analysis of strain, you can refer to the NPTEL video Analysis of Strain 3 from the course Lecture Series on Strength of Materials by Professor S.K. Bhattacharya. He is from Department of Civil Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.